question is like this: using the properties of determinants and without expanding, prove that this determinant is equal to 0. Okay. Now to prove this equation, we take the left hand side of the equation, which is given to us as delta is equal to a minus b, b minus c, c minus a, b minus c, c minus a, a minus b, c minus a minus b, b minus c. So to solve this question, first of all, I observe this determinant and find that the terms are such that if I take all the terms of a row, for example this first row, then here I have a minus b, b minus c, c minus a. So if I am going to add these terms together, so I am going to get a minus a, that is 0, b minus b plus b 0, and minus c plus c 0. Okay, so these terms add up to give me a 0. So keeping this fact in mind, I'm going to apply this property. C1 is operated as C1 plus C2 plus C3. Okay, that is to column 1 I add column 2 and column 3. So I know that whenever I add to any column the corresponding element of other column, the value of the determinant is going to remain unchanged. So if I am going to do the same for the column C1, that is, first I am going to add the column C2 and then C3, the value of the determinant is not going to change. Okay, so we can certainly apply this operation. Okay, so this can be observed that first I am going to add the elements of C2 and then I am going to add the element of C3 to C1. Okay, if there is any confusion. Okay, so the main point is that this operation can certainly be applied. Now, applying this operation, I am going to get a minus b plus b minus c plus c minus a as the first element of first column. Similarly, b minus c, c minus a minus b as the second element of the first column, and similarly this c minus a plus a minus b plus b minus c. Okay, so you can see that this is equal to 0. All the three terms would be equal to 0. So I'm going to get a determinant like this, and these two columns are going to remain as it is. And I know that if a determinant is such that it has all the three elements of a column as equal to 0, then the value of that determinant equals to 0. Therefore, this determinant would be equal to 0. Okay, so this is how we are going to prove this equation. Okay.